Hello! So today we're going to do something different. I'm going to use a different background, and we're going to see if I can't do this a little bit more efficiently to present you the subject. What we're going to be talking about today is slope. Now, big picture item, if we wanted to plot a line on a graph, the equation we would use is y equals mx plus b. Now, hopefully you know that x and y represent points on the graph as x comma y. Take from that, we have left m and b. Now, m and b are variables, which means they can mean different things, but m represents the slope, and b represents the y-intercept. Now, we're going to come back and talk about the y-intercept later, okay? So I'm not really concerned with what the y-intercept is. You just need to know that it's part of this equation we're going to put back together. What I want you to know is that the m represents slope. So anytime I write m, it means slope. Now, what does slope actually look like? Well, when I write an equation like this, and I put it in a graphing calculator, I get something like this, and that's a line on the graph. That line has a certain steepness to it. In this case, it's, well, camera's backwards. It's going down, right? Kind of crossways. So that steepness actually represents something. And as I move that around, it's going to change. And here we can actually see it. Let me add another line down here. And we'll add y equals mx plus b. And I'm going to add a slider for all of these. So the b we are going to pretty much leave alone, but it slides the line vertically up and down. Okay. And then my slope, my m, will actually rotate that line. Now notice, negative numbers, if you read them from left to right, they go downwards. Okay, and we read graphs like we read books, so we always read them from left to right. As we're reading from left to right, if it goes up, it's going to have a positive slope. And look, positive number, left to right, it's going up. If I have a negative number, left to right, it's going down. Okay. If I have a zero slope, I have an absolutely flat line. Okay. And I cannot have a vertical line. A vertical line would actually be something called undefined, and we will talk about it in a minute as to how that works. I hope. If I don't, click in the comments and say, you never talked about undefined. Okay, so that way I know to go back and do undefined. But I wanted you to see slope just references the steepness. Okay, it's actually going to be a ratio of steepness. So it's a measurement. It tells us the steepness. That's what it is. Okay, so if I wanted to measure the steepness of this line, well, anytime I'm using a graph, they're going to give me specific points. And the reason they give me these specific points defined on the graph is so that I know those points are specifically on that individual point. So I can know that this point is on -3, 2, and I know this point is on 1, -4. Because if I go elsewhere on this, it's, look at that, 1.6670. I'm not going to be able to tell exactly what that number is. So I need to stick with the known numbers. And then I've got this one too, 0, -2.5. I could guess that it was 2.5, but I don't know it's 2.5. So when they give you these points, use the points because we know it's there. Okay. So now the question is, how do I relate the steepness of a line? What am I measuring? Well, I'm measuring how far it's moving up and down. Am I on my pen? Yeah, I'm on my I'm measuring how far it's moving up and down versus how far it's moving left and right. Well, anytime I wanted to compare that stuff, that'd be a ratio. And one of the ways I represent ratios would be with division. So I could write it as a division up and down, left and right. But I don't like the way that is. So what's another way to say up and down? I can't say up and down, but I can say up, rise. We're going to replace this with rise. And then left and right, I want to use alliteration. Alliteration is the repetition of certain letters. Run. I'm going to say rise over run. I want to know how far the line goes up or down versus how far it goes left or right. Okay, so now if I'm going up or down, so let's talk about rise. Going up or down, up will be a positive number, down will be a negative number. When I talk about run, I only read books from left to right. I know about anime. I'm not talking about anime. I'm talking specifically traditional American books will always be read left to right. And that number will generally be a positive number. In next lesson, it could be negative, but that's just, it'll always be a positive number the way we're doing it right now, okay? So rise over run. Well, how do I figure out how far it goes up and how far it goes down? Hey, I have two known points. I can connect these points, but I'm not going to connect them with a straight line. No, I want to see the up and down and the left and right. So I'm going to look for the rise. Nope, rise should be blue because we rise to the sky. The rise is going to be a vertical distance. So I want to draw a vertical line from that point. Oh, it's purple. That's fine. And then I want to know the run. Okay, the run is going to be a horizontal line. So now I have, go away. There we go. I have the vertical distance traveled, the horizontal distance traveled, and they meet right here. So what I need to know is I need to know the distance this is going right here. So 1, 2, 3, 4, 5, 6. So that's 6, and now I'm going to measure my run. 1, 2, 3, 4. So my run is now 4. And look, I have rise over run. So I'm going to put that as 6. My rise goes up and down as 6 over my run, my left and right, which is 4. 6 over 4. Oh, wait, did I go up or down? I went down 6, right? So it's actually negative 6 over 4. But when we have fractions, always be thinking, can I reduce? And this does reduce. I can divide the top by 2, the bottom by 2. So that would give me a slope of negative 2 over, or negative 3 over 2. And I can check this really simply. So I'm going to use this ratio right here, and I'm going to go down 3, run 2, 1, 2. That looks like I'm pretty much on, but let's keep going and make sure I get to the right point. Down 3, 1, 2, 3, over 2, 1, 2. And I wound up at the exact same point. So this is definitely the ratio. Negative 3 over 2 is the slope, or the M, for this line. Fair enough. Hopefully that makes a little bit of sense. But let's practice another number. Let's look at another system. Get these cleared off. Actually, we'll do it this way. We're going to get rid of these two lines, and we're going to add these points and this line. And you'll see this is my equation, y equals mx plus b. So I'm using the equation to actually plot the line. I've put my 2 points in here so you can actually see them. and they have definite values. Okay, so again, remember, I'm looking for rise over run. So I'm going to look for that vertical line from the first point, and I'm going to look for the horizontal line from the second point, and now I'm looking at where do they intersect. Well, they intersect right here, and I'm just going to count. So I'm going down 1, 2, 3. So what's my rise going to be? Well, my rise was I went down 3, and I went down, so it's a negative. Now I need to know my run. How far did I go? 1, 2, 3. I ran 3. Rise over run, -3 over 3. But what is -3 divided by 3? Well, 3 divided by 3 is 1. Negative divided by a positive is a negative. So -1 in this case is my m. And that actually checks. For every 1 I go down, I move over 1. And it doesn't matter where on this line I am. Every 1 I go down, I move over 1. 1 I go down, I move over 1. 1 I go down, I move over 1. The ratio is -1 to 1. So I am moving exactly as I said. Let's try one more just to make sure we've got it solid. Turn off these 2 lines. And we're going to pull up this line, clear that out, boom. All right, now we're working with our orange line. I like the orange line. Did you notice this one changed? Which way does it go? Right, it is going up and to the right. Because it is traveling up as we would read the book, what kind of a slope do you think? Hopefully you said positive. So we should expect to find a positive slope. And again, I'm going to write it down so I can remember. Oh, now that's cool. It moves the points automatically up and down that line. I'm learning new things about this program every day. I like it. All right, so we are looking for rise over run. Now this time it looks a little bit different. So I'm going to look at, and in fact, I just realized my face is going to cut that off. So I'm glad I learned that. I'm going to first draw my horizontal line this time because it doesn't make sense to go up or down. And then I'm going to draw my vertical line. And where the 2 shall meet, that's where I'm counting to. So this time I'm going to be finding run first. 1, 2, 3, 4, 5. So my run is 5. My rise, 1, 2, 3, 4, 5. My rise is going to be 5. Well, 5 divided by 5 is 1. And it is a positive slope because I'm going up those 5 steps. There you go. And if you did rise first, you would get the exact same thing. It'd be up 1, 2, 3, 4, 5. And then I'd run 1, 2, 3, 4, 5. So you could do it either way. It's just habit for me to always go to the bottom side of the line. I don't know why. It just is. But this is going to be your slope, and it is represented by the letter M. That is our slope. Anytime you have a graph, make sure you're looking for the predetermined points. Don't just pick a random point that you think, because if you were trying to count from there to there, it's going to be very difficult to find how many jumps you make, however which way you go. Hopefully this helps. If it doesn't, let me know, and I'll try to figure some other way to approach this subject for you. But that being said, don't forget to like, subscribe, click the notification bell, and leave me a comment if you actually just leave me a comment. I'll see you in class tomorrow.